Here's a very interesting, slide that we probably need to keep in mind in terms of when we are looking at modeling in Cassandra. Some of the implicit expectation is going to be that Cassandra be able to deliver the data, Cassandra be able to accept the data in milliseconds, if not microseconds. Just to kind of get our head around what a micro and a milli is, right? So we have scaled that to human understandable time frame. So look at a nano, right? zero point 0.3 nanosecond. Let's assume we scale it that to a human, readable, human understandable 1 second. So if you want to go like that, the moment it switches from nano to micro, we are basically talking about 50 to 150 microsecond. It's about 2 to 6 days, right? And when we go from micro to milli, we are basically talking about months, and obviously continues to increase. So if you really look at from a system time frame perspective, a micro to a milli switchover is a significant switchover, isn't it? So when somebody says my Cassandra model is delivering the data in milliseconds, it is actually not a good statement. We should be really targeting microseconds. And if you can achieve a 2 digit microseconds, which is days in human, time scale, then I think our model is doing good. Low 3 digit microseconds is also okay, but you're basically borderlining. You're kind of on the borderline of, good and well, we need to really take a look at improving our data model. So milliseconds is not necessarily good in case of Cassandra. This is a very nice, comparison. Speaking of human understandable, quantum in terms of time, why don't we also look at from a data perspective as well? Take a look at this. If 1 byte of data is a grain of rice, terabytes is 2 container ships. A petabyte of data covers the entire Manhattan Island. Exabytes, we are not there yet. At least some of the large organizations probably they are, but for the rest of the organizations we're still in petabytes. Exabyte is covers UK 3 times over. That's a lot of grains. So my point is, we are looking at creating a system that can deal with massive amounts of data. Our expectations from this system is that it's able to deliver this data in a matter of microseconds. So I hope you are able to now really understand, right, what is the problem statement we are looking to address here. In addition to that, this is what we want. We are essentially saying, and this is an actual statement made by this gentleman, director of engineering, Netflix, long time back, 2014. 218 Cassandra nodes were rebooted, 22 nodes didn't come back up at all and got replaced. And that's happening on AWS. Zero Netflix downtime. Isn't that an amazing outcome? Isn't that something that businesses would love? Oh yeah, we have a partial outage, but you know what? My customers are happy. My customers are still able to access my application. So those are the expectations from modern data systems. I did not use the word database systems. I used data systems because I'm going to argue that is Cassandra a database or a data store at a later point in time? When somebody uses these two words, what are the attributes that comes to our mind? So before that, let's take a look at the types of NoSQL. Wide row or wide column. They also say wide column stores. That's okay. What we're going to say is here that the data for a given entity And don't worry if these things don't make sense yet, it will eventually. Think of an entity as you as a human being. Think of an entity as a machine. Think of an entity as a sensor. For that entity, the data on the disk will grow horizontally. And when we move on forward in the course, we will basically see how that actually happens on the disk. But for now, suffices to say that the data is going to grow horizontally on the disk. Columnar store. Columnar store is where the data of a given column across multiple records is stored together. For example, if I were to create an employee table, that employee table may have first name, last name, the employee ID. It can have, let's say, a salary column in there. So a columnar store is going to store all the salary information across multiple employees together on the disk. And the advantage of that kind of storage is it's great for analytics. For example, if I want to find out what the average salary is of an employee in this organization, since all the employee salary data is grouped together and stored contiguously on the disk, I really am not distracted by any other data. Great for analytics. Key value, giant big hash map. And we know what are the properties of hash map. Given the key, you can precisely figure out where the data is, go there, get the data. Using the same mechanism, you can go there and update the data as well. Basically, O1 performance. These systems are really amazing if you know what the key is. Typically in a hash map, and hash map as a programming construct has been around for a long time. You are not going to say that, okay, hash map, give me all the keys, let me iterate through that. You can do that. But is it the most optimum use of hash map? You would really like to work with the key to get the most optimum performance out of the hash map. Document database. MongoDB is a great example. This is where your data is organized as a document. Now, document not as in a Office document like a PDF or Microsoft Office Word document, nothing like that. This is essentially a JSON or a BSON, one of the two representations. I'm not sure, not a MongoDB expert, but that's exactly what it is. So think of it as kind of like a hierarchy. And if I were to take a JSON example, then it could be key and value. And the value for that key can again be key and value. So it is nested. And finally, graph-oriented databases. So this is where you store entities and relationships. This is where we store large amounts of data which establishes a relationship between multiple entities. So you can say a person who bought this product also is a likely candidate to buy these products because this individual is related to these other individuals and they all seem to share the similar kind of attributes. So these kind of information is really, really useful in marketing and positioning the products and all that. So where does Cassandra belong? Cassandra is at the very top. Wide row store. Not top as in like, this is not ordered in any manner. It's just the very first item. So I just wanted to be absolutely clear. Cassandra is not a columnar store. There are quite a few references out there that says Cassandra to be a columnar store. It's actually not. It is a row-oriented store. And we will see when we talk about row-oriented store, what does it mean?